Hello, what's up guys? Welcome back to my channel. Okay, now we already been through first my first video in this chapter. So this chapter already have like 3 videos now. Okay, the first one is the introducing of big data, what is big data problem, why is need all this technology or so on. And then the second video I explain everything about Hadoop, start from the Hadoop analogies, and then we go through the Hadoop core components, which is HDFS, MapReduce, and lastly Hadoop Yarn. Okay, so we finish with Hadoop, which is one of the technologies in big data. Okay, this is the last part of this video in this chapter 3, introducing big data technology, which is we're going to go through NoSQL. Right, there is a story why it's needed. Not only this NoSQL is needed. I think you can go through that by yourself lah. Okay, what I'm going to explain in this video only just technologies involving this NoSQL. Okay, NoSQL, okay, database, which is stand for not only SQL. Okay, this has been introduced into in 1998. Okay, that was like years ago, 20 years ago. Okay, to a better term that will be NoSQL Quran. It was introduced by Carl Stroes. Okay, this database is a non-relational data management system. Okay, it does not require a fixed schema, so there's no tables. Okay, it avoids joins and it's easy to scale. Okay, the major purpose of using this NoSQL database is for distributed data stores with homogeneous data storage needs. Okay, we're still on the distributed data stores, but now we're talking about the homogeneous data storage needs lah. Okay, NoSQL is used for big data in real-time web apps. Okay, for example, companies like Twitter, Facebook, Google, or all these big companies that has unstructured data. Okay, obviously, okay, not all data is structured that can easily use Hadoop. So that's why we need this NoSQL database lah. Okay, traditional RDBMS uses SQL syntax to store additive data for further insight. Okay, that's his traditional RDBMS. For this NoSQL database system, it encompasses a wide range of database technology that can store structured, semi-structured, unstructured, and polymorphic data. So it's not just focused on the structured database only. So now we can structure all type of data with all these technologies. Okay, we will go along all these technologies in this NoSQL database along this video. Okay, just bear with me. Okay, now we start with this what is the difference between SQL database and NoSQL database. So for SQL database, it is a relational and it's analytical. It's all up. Okay, for NoSQL database, it's a column family. There is 4. Actually, now it has 5 already. Okay, first there is a document base. Okay, second is a column, and then key value graph, and the latest one is a cache system. Okay, this two difference between SQL database and NoSQL database. So there's a type 5 different type of NoSQL database, and for SQL database there are only 2, relational and analytical. Okay, we will go through this column, graph, document, key value in this along this video later on. Okay, next, why we need this NoSQL? Okay, the concept of this NoSQL databases become popular with this, like I said before this. Okay, with this large company like Google, Facebook, Amazon, Twitter, and everything lah, because they have a huge volume of data. Okay, this big company, they need a system that response time is shorter. Okay, so that's why the NoSQL database is needed lah. Okay, for RDBMS, it takes time to respond, so it becomes slow. So that okay, let's see in the figure here. Okay, we have the scale up and scale up. Okay, let's see for the traditional RDBMS. Okay, it uses scale up, vertical scaling. Okay, for the Alternative issue, okay, distribute database root on multiple hosts. So we use the scanning out. Okay, to get more clear, just imagine here. Okay, let's say we have an apartment. Okay, an apartment, one building. Okay, one building. Then we have more tenants, more people that want to join mean to stay at this apartment. Okay, so which is this is not technically logic, but just imagine it. Okay, so more people want to stay at this apartment, so we build more storage for the apartment. Okay, we put another storage. Okay, up. So the apartment become higher, but at least it cannot go on like that forever, because there is some extent where building has to be that store only, cannot be more taller and it reach the sky and whatsoever, be collapse, fall down, and then it cannot be done lah. Okay, that's why the scale up has a limitation. Okay, that means to have more RAM, more CPU, more HDD, it is sometimes it will be has a limitation. Okay, that's why we need this horizontal scaling lah, scale out. So when people want to stay at the house, okay, we build more apartment, same apartment. Okay, vertically, horizontally. So that means it can be built more. Okay, that's no problem, because they have a lot of land to build the apartment. Okay, just imagine, but no need to cutting the tree, I guess. Okay, this is the community hardware that I explained in the Hadoop. Okay, so scale up is better than scale up. Okay, so NoSQL database is non-relational, so it is scale out better than relational database. So this the solution for NoSQL. That is why people is more prefer NoSQL than the traditional RDBMS. Okay, because traditional RDBMS will scale up instead of scale up, right? Okay, now we go to types of NoSQL databases. Okay, I already explained before this. There are 5, but I don't include the cache system in here, so we only focus on 4. Okay, which are key value. Okay, key value base. For example of technologies under key value is Tokyo Cabinet, Ready Server, Memcache, I don't know how to pronounce this. Okay, as Clarice. Okay, and then we have document base. Okay, example MongoDB, CouchDB, OrientDB, and RavenDB. Okay, this document base is the most popular. Okay, the most popular database in this NoSQL. And then we have this column base. Okay, the column oriented graph. Okay, for example, the Bigtable, Cassandra, based on hypertable. Okay, this column base is optimized reading and writing. And then the last one is graph database. The example is Neo4j, Infogrid, Infinite Graph, PlotDB. Okay, all this I'm going to explain in more detail later on. Okay, we start with this key value pair base. Key value pair base. Okay, this is the most the simplest type of NoSQL database, and it's also extremely fast. Okay, so how it work? Okay, data is stored in key or value pairs, like a table here. It is designed in such a way to handle lots of data and heavy load. Key value pair storage databases store data as a hash table where each key is unique. Okay, it's stored in this table like this. Okay, but it has a unique key. Okay, in the JSON, okay, in the JSON file, it has a kind of hashtag, so it will be confused with other file. Okay, Is stated here. For example, a key value pair may contain a key like so website associated with a value like Guru said 1999. Okay, so that's because of this same similar. Okay, key value pair. So we might want to assign a unique key lah. Okay, it is one of the most basic NoSQL database lah, and also the first one. Okay, this kind of NoSQL database is used as collection, like dictionaries, associative arrays, and others. Key value stores help the developer to store schemaless data. So it will be schemaless data. Okay, they work best for shopping cart contents. Okay, I think probably Shopee, Amazon. Okay, I will adopt this type of database. Right. So there is one example of this database, which is Voldemort. Okay, this is a distributed key value storage system. Okay, a little bit explanation about Voldemort down here. Okay, it is used at LinkedIn. Okay, if you use LinkedIn, so it is used for the database. Okay, data is automatically replicated over multiple servers, so that data to avoid the loss of data. Okay, it also partitioned, so each server contains only a subset of total data, and then it provides tenable consistency. Server failure is handled transparently, and then it has pluggable storage engines and pluggageable serialization. Okay, each node is independent. Okay, and then it also has code single node performance and support for plungible data placement strategies to support things like distribution across data center that are geographically far apart. So it's very good for some social media fish like LinkedIn. Right. It's another joke. It's a joke here. There is another Voldemort. If you watch Harry Potter, you might get this joke, or else just watch that. Right. We go to the second one, which is a column base. Okay, column base work on columns. That's why its name is column, and based on big table, okay, paper by Google. So every column is treated separately. Values of single column database are stored continuously. Okay, they deliver high performance. Okay, and then column-based NoSQL database are widely used to manage data warehouses, business intelligence, CRM, library card catalogs. Okay, so the example can be as a HBase, okay, Hadoop, one of Hadoop component, Cassandra. I type HBase 2 times. Okay, that is how much important HBase are. Hypertable. Okay, that's a example of a column-based database. Okay, this is Cassandra. If you open the website, you can see like this. So there is a little bit explanation on Apache Cassandra. Is one of the Apache project. Okay, you can read and get more information on Cassandra at this website, or you just can Google Apache Cassandra. Okay, as it is an open one of the Apache project, so it's an open source. Okay, distributed NoSQL database. Okay, it's began internally at Facebook, so Facebook used this Cassandra. Okay, it was released as an open source in July 2008, which is a long time ago also. Okay, it delivers continuous availability, zero downtime, high performance, and linear scalability. Okay, that's why Facebook adapt this kind of database. Okay, you can read the rest by your own, I think. Alright, the next one is document-oriented database. Okay, this NoSQL database stores and retrieves data as a key value pair, but the value part is stored as a document. So it's same like the first one, the key value, but the different, okay, here is the value part is stored as a document. That's why it's called document-oriented. The document is stored in JSON or XML formats. Okay, the value is understood by the database and can be queried. Okay, in this diagram, okay, on your left, this one, okay, you can see we have rows and columns, and in the right, this one, we have document. So columns, okay, rows, and documents. Okay, now for the relational database, you have to know what columns you have and so on. However, for document database, you have data store like JSON object. You do not require to define, which make it flexible. So this is very flexible database. Example of technologies involving this document-oriented database are Amazon Simple Database, CouchDB, MongoDB. I think MongoDB is the most popular one. Okay, you can check out that on the MongoDB website. Okay, some popular document-originated DBMS system. I'm not going to explain. I'm not going to explain every each technologies introduced in every type of database here. You just going to check by yourself lah. Okay, not enough time to explain everything. Okay, I don't know how to explain this Raya or Ria. Okay, it is a distribute NoSQL key value data store that offer high ability, fault tolerant, operational simplicity and scalability. Okay, this is one of the document-based product. Okay, more information you can check out on the website, and I think you can read all the details about this technologies on your own. Right, the last one we have graph base. Okay, a database. The graph type database stores entities as well the relation amongst those entities. So the entity is stored as a node, okay, with the relation as edges. Okay, this is a person, find with this person. Okay, and the person live in the city, and this person likes the city. Okay, that's like how the relationship lah between these every nodes. Okay, every node and edge has a unique identifier compared to a relational database where tables are loosely connected. A graph database is multi-relational in nature. Okay, traversing relationship is fast as they are already captured into a database, and there is no need to calculate them. So there is no calculation involved. Graph-based database mostly used for social networks. So I think Twitter might use this kind of network graph-based because it's linked with the Twitter and one. Okay, there are some popular graph-based database here: Neo4j, Infinite Graph, OrientDB, FloatDB. Actually not very familiar with this kind of database, but I think you can check out myself. Okay, then we go to the CAP theorem. Alright, CAP theorem as a CAP. C stands for consistency, A stands for availability, and P stands for partition tolerance. Okay, so that is why it's called CAP theorem. CAP theorem is also called Brewer's theorem. Okay, it stated that it's impossible for a distributed data store to offer more than 2 out of 3 guarantees. So that means out of these 3, consistency, availability, partition tolerance, the distributed data store can only offer 2 out of these 3. So that means if it can offer consistency and availability, it cannot offer partition tolerance. If it does offer availability and partition tolerance, it can offer consistency. So it only can offer 2 out of these 3, cannot all. So it's impossible to have these 3 together. Okay, what is consistency? What is availability? What is partition tolerance? Consistency is when the data remain consistent even after the execution of an operation. So it's remain the starts doing by the database, so keep doing the same thing. Okay, so that means consistent, like you doing the job every day, you doing good job every day, you submit all the tasks on the time, so that's consistent. Okay, that means once data is written, any future read request should contain the data. For example, after updating the order status, all the clients should be able to see the same data. So that's consistency. Okay, it's very easy to understand. Okay, and then availability. Okay, that means the database should always be available. Okay, it should not have any downtime. So no downtime, that means it's always available. Okay, and lastly, partition tolerance. Okay, it means that the system should continue to function even the communication among the servers is not stable. Okay, for example, the servers can be partitioned into multiple groups which may not communicate with each other. Here, if part of the database is unavailable, other parts are always unaffected. Okay, so that means it's not a fault of has any misfunction. Okay, out of this three, only two is allowed in this distributed data store. Okay, so you have to choose. Uh, the CAP theorem. Okay, there is another term beside CAP theorem, which this term is eventual consistency. Okay, it means to have copies of data on multiple machines to get high ability and scalability. Okay, thus changes made to any data item on one machine has to be propagated to other replicates. Okay, this consistency, eventual consistency, is based on this base. Okay, base. Okay, which is used in a many NoSQL system. Okay, base is stand for basically available, soft state, eventually consistent. So that is base lah. Okay, basically available means database available all the time as per CAP theorem. Okay, it's continue from the CAP theorem. Okay, just now. Okay, that soft state mean even without an input, the system state may change, and then eventually consistent. Eventual consistency means that the system will become consistent over time. So this base is used in the NoSQL database. It is replacement of the ACID. ACID is used in the database, the standard traditional database. Okay, so instead of ACID, we have base. Okay, you might want to remember that. Right, then we go to the last one. Okay, advantages of NoSQL. Okay, there's a lot of advantages of using NoSQL. It can be used as primary analytic data source, big data capability, no single point of failure, easy replication, no need for separate caching layer. It provides fast performance and horizontal scalability because of scale of. Okay, can handle structured, semi-structured, and structured data with equal effect. So all type of data can be handled, no problem. Okay, object-oriented programming, which is easy to use and flexible. Okay, and then it also donate a dedicated high-performance server. It support key developer language and platform. It's simple to implement than using the traditional DBMS. Okay, it can serve as a primary data source for online applications. Okay, like LinkedIn. Handles big data. Okay, access distributed database, eliminates the need for specific caching layer, and offers a flexible schema design. Right, that's all advantage, which is a lot. Okay, but even with that lots advantages, there are also some disadvantages. Okay, the sum is 8 here. Okay, first one, no standardization rules, limited query capabilities. RDBMS database and tools are comparatively matured. It does not offer any traditional database capabilities because it's more advanced. Okay, when the volume of data increase, it is difficult to maintain. Okay, doesn't work as well with relational data, and the learning curve is steep for new developers. Also, open source options so not so popular for enterprises. Okay, the option there's a lot of option actually. But this was taken from the 2013 book, so I think this is not valid now. You can cancel it out. Right, now we have the summary of NoSQL. Okay, so the summary here, NoSQL is a non-relational MS. Okay, it does not require a fixed schema, about join, and is easy to scale. Okay, the concept become popular after all these giant company introduced it, like Google, Facebook, Amazon, LinkedIn. Okay, and then it was introduced in 1998. Never follow the relational model. It is either schema free. Okay, that's its disadvantages, but I think we can get over it. Okay, there are 4 types. Okay, as I already explained. Okay, it can handle all type of data. Okay, but it has to refer to CAP theorem and basically available self-state eventually consistency. Okay, the term eventually consistency means to have copies on data on multiple machines to get a high ability and scalability, and it's offer limited query capabilities. Okay, that should be disadvantages. Okay, last. before we finish with this chapter is textual ETL processing. Okay, what is ETL? This is extraction, transformation, loading. Okay, the definition itself. Okay, ETL is extraction, transformation, loading. The ETL, what is ETL? Is the process in data warehousing for pulling data out of source system and putting it in data warehouse. So we take and we put it back, something like that. Okay, here is a little bit explanation on textual ETL processing. Okay, okay, in this figure, it is shown the concept of textual ETL. Okay, textual ETL contains all this: textual ETL rules engine, user interface, taxonomies, output database. So this engine. Okay, user interface. Okay, and then we have taxonomies. And then we have output database, okay, which is the output. It can be as a visualization. Okay, we go for the first one, textual ETL rules engine. Okay, this is a core processing engine. Okay, like Hadoop Yan. Okay, there is processing. Okay, to pass large unstructured data and extract value from the passing for integration, the rules engine executes as a series of data processing steps and processes the data. Okay, the following are the algorithm that are incorporated into the rules engine. So this engine use this algorithm: classification, clustering, affinity, and proximity. These four algorithm. Okay, the additional integration process in technology includes taxonomy. Okay, this is the additional techniques: integration, metadata integration, and master data integration. Okay, then we have user interface. Okay, so that the business users can create data processing rules in a drag and drop interface and in a free form text interface that supports 16 languages for processing. Okay, that's a lot of processing languages. Okay, then we have these taxonomies. There are several categories of data that can be processed by any enterprise, and the most effective way to process a multi-structured and multi-hierarchical data is by integrating third-party taxonomy libraries. Textual ETL supports over 40,000 known taxonomies in 16 languages of data enrichment and processing. Okay, lastly, we have the output database. Okay, textual data ETL can write the output to any RDMS, relational database, or NoSQL database. So it's optional. Okay, the results are key value pairs. Okay, one of the NoSQL database that can be used to integrate the structured and structured database. Okay, visualization is also one of the output. Okay, this textual ETL is currently developed and architect. Not currently developed, already developed, I think, and architect on Microsoft technologies and can support Hadoop and NoSQL technologies. Actually, this Microsoft technology that we talk about is Azure, I think. It's currently developed during this year, but this year of this textbook system, but now it's already available. Okay, and can support Hadoop and NoSQL technology. Okay, we're talking about Azure there. Okay, basically textual, that's how textual data processing is it. Okay, I think, alright, I think that's all for this video. I think you're going to see me in the next video with the new chapter 4. Okay, see you next time. Thank you for watching.